Hello everyone and welcome to this new Unreal Engine 5.6 tutorial. In this video, we will be creating a path system for our AI, meaning the AI will walk in a predefined path back and forth, or he could just walk once. Okay, so at the end of this video, you will have something similar to this. The AI will also have an option to wait at a specific location using these target points and this wait time parameter. So at this target point, he waits 2 seconds, and at this target point, he waits 5, and this AI over here, he waits 2 seconds at this target point. Okay, so if you want to create something similar to this, stick around till the end of the video. First, we need to create few blueprint classes. First one is a component, an active component, and let's call it bp underscore path component. And we want also to create a class from target point. Okay, let's call it bp underscore path target point. And we want to create an enum, and let's call it e underscore path type. Okay, so let's first open the path target point, and inside we only need to create one variable, and let's call it wait time of type float, and let's give it a default category of parameters and instance editable and expose on spawn. Then we need to create a function inside our path component, but before we need to create some variables. So the first variable is waypoints of type bp target point, bp path target point, and it's an array. Let's set it as private. Second is a boolean. Let's call it be forward or forward. Okay, and by default it's true. Third is the path type. So path type. Okay, let's make it private also. And here too. Great. Now let's create a first function and let's call it get waypoint or get next waypoint index, because it returns an index. So the output we want to return an integer, and let's call it next index. Okay, first we want to get the waypoints array. We want to get the length of it, or before let's check if it's empty. If it's not empty, or get is empty. If it's empty, we want to return -1. Okay, now if it's not empty, we want to promote this to a local variable. So let's call it num_points. Okay, then let's make let's get the path type and make switch. But right now our path type is empty. So let's add 3 values here. First one is once, then we have loop, then we have PingPong. Okay, now for the once, we want to return, let's add a return node. Okay. We need to get the current index you are in, but we don't have right now, so we need to pass it as a parameter. So here, let's add a new parameter of type integer and call it current index. So now we can get the parameter, the current index. Then we need to add +1 to it. Okay. Then we need to check if it's bigger or equal to the total array points. Okay. And we need from here to add a select node, and the return value will connect it to the return node. And if it is bigger or equal to the maximum number of points, that means we have reached the end and we want to return -1, no more waypoints. But if it's not, we need to return the next index. Okay. Now for the loop, we need to copy this, the current index +1, and we need to add a modulo by the maximum number points. This means if it reaches, let's say we have 5 and it reaches the last one, the 5th, it will go back to the first one. And if, for example, you are going the opposite way and it reaches the first number point, it will go back to the last one. Okay, that's what modulo does. If you modulo by the maximum number, that's what it does. So let's copy this return node and return this. Now for the PingPong, it's a little bit different. We need to get, let's copy this here. We need first to check which direction we are moving. So based on that, we decide if we add by 1 or we subtract by 1. So forward, let's take a select node. If you are moving forward, we need to add 1, and if you are moving backwards, we need to add subtract -1. Now, after we do this, we need to check if we are at the last number point, at the last waypoint. Okay. If true, we need to set the forward to false. That means we are going backwards, and we need to add a return node, and we must return the number points minus 2. But let's first make a quick check. Let's say if we have number of points, if we have more than 1, then if we have, then we subtract 2 from it. If we don't have, then we simply return 0. So this means if we have, let's say, 5 number points inside the array. Okay, so let's say we have 5. The reason we are doing -2 is because the index starts, so first element has 0 as an index. Okay, and here we are returning an index. So let's say we are at the last one. Okay, so here we are checking if the current index, which is 4, and we are moving forward, so 4 plus 1 is equal to 5. It's bigger than the it's equal to the array elements. It's 5. So we need to go back. Okay, we need to go back, and we return an index of the total elements, so 5. Okay, minus 2, because right now we are at the 4th index, right? So we need to return the next index, before the 4, so that's 3. So 5 minus 2 is equal to 3. Okay, now we could do something like this, maybe minus 1. Okay, so now we are at the fourth index, we return minus 1, goes to 3. Okay, it's the same thing. Then we want, if this is false, if we didn't reach the end yet, we need to do another check. Oops. And we need to check if this is smaller than 0. This means if it's true, then we have reached the end, but in the opposite way. So technically we have reached the start. So we need to set the forward to true. And let's copy this and this and this. And we need to check if we have more than one. Then we return the first index after the 0. So that's 1. And if you have only one, we will simply return 0 as an index. Now, if none of these two is true, then return, simply we return this. Okay, so if we haven't reached the end or we haven't reached the start, then we continue doing this. Okay, so this function is over. Now let's create another function and let's call it get waypoint at index. Let take a index parameter. And from here, let's clear this. From here, we get a copy from this index and we return the waypoint. So bp underscore first target point and we return it. Now we need to do one more thing. We need to create two custom events. First one is called set waypoints and the second one is called set path type. So these two setters are responsible to set the waypoint and path type for each MPC. Okay, so this one takes the parameter of path target point and an array, new waypoints, and this one let's set this waypoints array, and this one takes a parameter of path type, new path type. Okay, and you set this one. Okay, so we are done here. Now let's go and create our AI class. So let's go to blueprint class, character, and let's call it bp underscore AI or path AI. Now here, let's set the mesh for it. And the blueprint animation. And inside the components here, let's add the path component. Okay. And inside the event graph, inside the begin play, we need to get this component. And if it's valid, okay, we need to call the set waypoints function, and we need to call the set path type function. Okay. And let's promote this to a variable, waypoints. And this one, path type. Let's make it instance editable, expose on spawn, and parameters. Pass. Okay, great. Now, if we drag our character here, our AI, if we look for parameters, we can see these waypoints and the path type. Okay, now if we drag a blueprint target point inside the scene, and we go back to our character and we click plus here, we can see that this target point is now visible and we can set its value. Okay, let's make more than one. Okay, let's make one here and make one here. Okay, now let's say I want the AI to roam from here to here, back and forth. Okay, so first I need to set the waypoints. So that's 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5. And let's pick this one as first, this one as second, this one as third, this one as fourth, and this one as fifth. And I want the path type to be ping pong, to go from here to here and from here to here. Now for the loop, it will go from here to here, then it will come back straight here, then from here, straight here. The ping pong will go from here and then back like this, the same route. And the ones will go once till here and he will stop. Okay, great. So now if we start the game, the AI will not move, obviously, because we didn't tell him to. So let's go ahead and create a behavior tree. And let's call it behavior tree bt underscore pass. And let's create a blackboard. Let's call it bb underscore path AI or whatever. Okay, now inside the blackboard, we need two variables. First one is an integer, and let's call it current waypoint index, and the default value of -1. This is essential because if it's 0, he will always skip this one. He will go straight to this one because for him, he is already at this index, at this waypoint, because it's 0. But we have to set it as -1. So he can actually calculate the next index for this, which is 0. If he's at 0 already, he will not calculate it. And the second one is a, sorry, not enum, float. And let's call it wait time. Okay. Now in here, let's make a sequence. And we need to create, first let's add this wait here and have this wait time, Blackboard key. And here we need to create a custom task for the AI to roam, to move along the path. So let's create this task and let's call it move along path. Now let's override the execute AI and let's promote these to a variable. Okay, and from the control pawn, we need to get a component by class, and the class is the path component. Okay, and let's promote it to a variable, path component. Then let's create a custom event. Let's call it move to next waypoint. And another a function, let's call it calculate next waypoint index, and it returns an integer, new next index. Now we need to get the value of this waypoint index inside of the blackboard. So let's get the Blackboard. So get owner's Blackboard. Okay, and get value as int. And for the key name, let's make literal name, and paste the name of it. And let's promote it to a local variable. Then we need to get the path component if it's valid. We need to calculate or get next waypoint index, and we return this. And the current index is this local variable. Okay, but let's go here again and let's actually make this one pure. Okay, like so. And this one as well. Let's make it pure. Now let's get the path component, or let's get this calculate next waypoint index. Let's also make it pure. And constant. Okay. Now we need to, from the path component, get waypoint and at index. And the waypoint is this one. And the index is this one, sorry. Then we need to promote this to a variable. So let's call it current waypoint. We need to check if it's valid. And now if it's valid, we need to set Blackboard value as int, or as an int. And the int literal name is the same as this one, the current waypoint index, and the value is this one. Then again, we need to set value as float. Let's copy this, change the name to wait time, the same name you created here. And the value is, we need to get the current waypoint and get the wait time from it. Okay, then we do AI move to, and the pawn is the controlled pawn. The target actor is the current waypoint. And on success, we need to create a new custom event. Let's call it handle move completed. And let's call it here on success. And when we finish the move, when we reach the target point, we need to check if it has any wait time. If it does, we need to finish executing this task in order for the first, let's call it here. So let's go move along path. If it has a wait time, okay, when we finish, if it has a wait time, we need to finish executing this so it goes here and we do the wait. Okay, and if it doesn't, we simply move to the next waypoint. So here, current waypoint, convert to validate get, get wait time. If it's bigger than 0, we finish executing with success. And if it doesn't, we simply move to next waypoint. Now, inside the execute AI, we need to also call move to next waypoint at the start. Okay, so let's close this and this and this and this. Now inside our blueprint path AI, we need to override the onPossessed event and from the new controller, we need to cast to AI controller, and we need to run the behavior tree. And what else? That's it, I guess. So now it should work. Okay, so it's supposed to go from here to here, and from here to here, back and forth. So yeah, as you can see, it's moving, but for some reason it's floating, and that's because inside our pass AI and inside the character movement, we need to look for use use acceleration for pass. We need to take this to be true, and we need to make sure fixed pass breaking distance is 0. Okay. Yeah. Now it's working, but for some reason it's slowing down when it reaches one target point. Yeah, let's try and put like 10,000 in here, something very high. Yeah, now it's working. He's not slowing down when he reached the location. Let me try to make this like 50, for example. Yeah, so now let's try the once type. Yeah, as you can see, it stopped when it reached the location. And let's try to make it loop. Yeah, as you can see, the AI didn't go back from where it came. It took the shortest path all the way to his first waypoint. Great. Now let's make another AI. Let's copy paste this. Let's copy this. This one here. This one here. Okay. Now let's clear this. Okay. Now let's go and look inside the construction of our AI, and let's create dynamic material instance. No, not this one. Create dynamic from the mesh. Okay. And this one and the array element index one. Set value vector parameter value paint tint, I guess it's called. I'm not sure. Yeah, that's what it's called. Let's promote this to a variable and let's call it outer skin. And let's promote this to a variable inner skin. Parameters, color. Okay. Now let's change the color of these AIs. So for the outer skin, let's give it maybe yellow, and inner, let's give it like this, and here let's make it blue and white. Okay, now also let's try the wait functionality if it's working. So I want this AI to wait at this target point for 2 seconds. Then I want him to wait at this target point for 5 seconds. And I want this AI to wait at this one for 10 seconds. Yep. As you can see, this AI is waiting. And this one as well. Now the reason this AI didn't wait on his way back, that's because he went, it's set on loop, the pass type, and he took the shortest pass. So if we set it as ping pong, he will keep waiting if he goes back and forth. So let's make it something shorter like 2. Now he will wait for 2 seconds. Now on his way back, he will also wait 2 seconds. Yep. So yeah, that's it guys. I hope you've enjoyed this tutorial. Don't forget to like, comment, subscribe for more content. And I hope to see you next time. Take care.